Hello friends, in this video we will be talking about Hive architecture and a little bit of Hive databases. Hive uh, comprises of three important components. One is Hadoop core component itself, which is HDFS and MapReduce framework. Second one is Metastore, and third one is bunch of jar files which actually compiles SQL type of queries into MapReduce based Java programs and runs using the MapReduce framework. So let me demonstrate real quick using a very small data set called deck of cards. So again, I'm going to the Cloudera VM, and I am yeah, most likely if you have internet access, you should be able to access internet using Mozilla Firefox in your Cloudera VM. You can see the Mozilla Firefox icon on the top. You can click on that and it will launch the Firefox if it is not already open. And you can give this path github.com/dgadiraju. You can click on data, and in cards there is a sample data called deck of cards.txt. So you can copy this 52 row deck of cards into a text file using VI. So I'm a VI editor in the terminal. So I came back to VI editor, and here I'm in the home directory called /home/cloudera, and I would like to create a directory called demo -p demo data cards, and then I want to go to that directory, and then I would like to create deck of cards.txt. I to go to insert mode and right click and paste which we have copied from the GitHub link and exit from it. So now data is copied into this deck of cards.txt file. This is under the local file system which is on Linux, and now we will copy this file from this location to HDFS, and then we will create a table on top of that. You will understand how it works. Okay, so you can run Hadoop FS instead of Hadoop command. Let's run Hive command itself. First, let us create the table. So there is a script which I am using, and this will be copied to GitHub as well. So to get this script from the GitHub, you have to go to GitHub account dgadiraju, and all the code will be under code, and under Hadoop you can see a directory called edw, and there is a directory called Hive under that. So code Hadoop edw Hive, and there is a hive demo.txt file. Right now it is empty. Once I finish the demo, I will commit this, and you will immediately able to use this as reference for your practice. Okay, so let me go here. Instead of using text edit on my Mac, I'm actually going to terminal. So this is the path to which I have copied the file, and then don't worry much about the syntax and semantics of this. You will understand later. For now, just to explain you Hive core components, I am creating a sample Hive database, and I will show you how the data is copied to that into a table into HDFS location, and I will tell you about the relevance of the Hive metastore. So I am talking about this picture. So by this simple exercise, I will try to explain how the data will be stored in DFS, how the metadata will be stored in metastore, and also I will explain the role of the driver. So these three are the most important components of Hive. Okay, so let me copy this, and I'm going to the Cloudera VM, and I'm launching Hive command prompt. So if you run Hive command, it will launch Hive command prompt. You will understand more about Hive command prompt once we complete the architecture. First, if you want to run HDFS commands, you have to use DFS, and then you have to give the sub command, and you can hit enter, and there is nothing here. So if you just run DFS and hit enter, it is erroring out. So this is the actual command to see the HDFS and the details in the HDFS. So don't worry about this directory, just understand that this is a HDFS directory. Don't think too much about it, it's just a HDFS directory. Okay, I just hit enter. There are bunch of directories here. Okay, now I am creating a database which is called as cards. It's a Hive database, and I have created a directory called cards. Hit enter. Before creating the database, I have ran dfsls command on user Hive warehouse. There are a bunch of directories, but none of the directory name is cards, right? So now run it again, run the same command again, and now you can see a directory called cards.db. So when you actually create a Hive database, it will create a directory called cards.db. And now let us see what is in the cards.db. There is nothing here because we just created the database. Now let us create the table. So this is the sample of create table command. We will understand more about it later when we talk about physical data modeling. Paste. Okay, so I have created a table, and I am again running the ls command now. Earlier it did not return anything here. Under cards.db it did not return anything. Now if you hit enter, okay, I did not switch to, I have created the database, but I have not switched to the database. So to switch to the database, I have to use command, and now I will paste create table command. Now let us run the dfs-ls command. You can see in the directory called deck of cards. So a table in create table command, a name that is used under create table command, with that name a directory will be created, and under the database we are connected to using use command. So first we have created a database, then we have switched to the database called cards, and then we have created a table with name deck of cards, which actually created a directory here. Okay, and now there is a command called load command to actually copy the data. Okay, here the file name is okay. So this is the command which will actually copy the data from this location, which is local path in the Linux. It is not HDFS. HDFS also a file system which will be which you can interact with the Hadoop fs command or dfs command, which we are doing in the terminal in our Cloudera VM. Now I am pasting that. Hit enter. So that now we will see what is happening under the deck of cards. directory, which is created when we created using the table. As we after creating the table, we didn't run this command. If you would have ran this command, it will not have returned anything. After that, we'll ran the load command. So when the load command ran, it copied this deck of cards.txt file from local file system into HDFS, and this is the HDFS path. If you try to search this path in Linux by going by using ls command like this, you will not find anything, because that is HDFS path, and only Hadoop commands can actually understand that path. Linux cannot understand that path. Anyway, so now we created a table. We loaded data into the table. So that is what the DFS portion of it. Okay. Now let me run a query. So I am switching to the database called use cards, and then you can run show tables to list the tables. We have only one table, and you can run this query. So what is happening is it is submitting the query as a MapReduce job. So between the query and the MapReduce job, it will generate Java code, and it will be compiled as jar file, and that jar file will be actually submitted as MapReduce job. Anyway, you need not worry much about it, as long as you just understand that Hive is nothing but SQL type of queries. If you try to write select commands, and those will be compiled as MapReduce programs and will be run in Hadoop, that is more than enough. So that covers the bottom part of this picture. Hadoop core component is one of the main component of Hive, and the second one is metastore. Now let me explain what is metastore is. So the result is 52. As there are 52 records in the table, it returns 52. Now exit, and as we have first, let us see what data. So Hive metastore, as the picture suggests, is nothing but a database. Okay, so let us see details of this database first. So for almost all the software products, there will be parameter files. Similar to that, Hive also have a parameter file called hivesite.xml, and the path where the Hive parameter file will be is etc hive conf. So etc is the standard directory under root, and then Hive is the name of the tool which we are referring to, and conf is the standard directory as part of the Hadoop ecosystem tools. And then if you do ls-ltr, you will see a hivesite.xml file. You can actually view hivesite.xml, and it will tell you what type of database it is using, database name, and all those things. So it is using MySQL database, and the database name in the MySQL is metastore, and it uses Hive as username and password as clouded as password. So now you can come out of this, and you can say MySQL -u Hive -p, and password is Cloudera. And if you say show databases, it will list all the databases to which Hive user have access to. As the hivesite.xml file suggests, the database is metastore. So this metastore is nothing but the cylinder here, which is represented as metastore. Okay, and if you go back to here, now you can say use metastore and show tables. So if you look at the show tables, and there are a bunch of tables here, which as the name suggests, they are nothing but meta store tables, metadata tables. So when we actually ran the Hive command, Hive create table command like this is nothing but a metadata to a table to a file that is stored under this location. Sorry, not this location. Where is it? Under this location. Okay, so so the location is this, and the metadata for the data that for the files that will be copied under this directory is represented by here. If you see, it has the column names and it has the delimiters. So if you are familiar with external tables in Oracle or MySQL, it is similar to that. Okay, so all this is nothing but metadata. Actual data is in HDFS, and this metadata is actually stored in these tables which are under metastore. Okay, so let us see one table called TBLS. You can actually select star from. TBLS is here. What? It is saying does not exist. Reading table information for complete of table and column names. You can turn off this feature to get a quicker startup with -CA. Yeah, so it is case sensitive. That's why it failed. So if you see, there are three tables. We have created this deck of cards under two different schemas. That's why it is showing two. Accidentally, we have created in a default database before switching to cards. That's why you see this twice. So this is what metadata is all about, and this cylinder on top, which is says metastore, actually stores the metadata of your Hive tables. And then there will be bunch of jar files. So you can actually go to click on exit, and then you can run this command find /-name, and there are a bunch of Hive related jar files which will actually take care of converting the SQL type of queries into MapReduce programs and submitting it in the Hadoop clusters. So that is the Hive architecture. The three major components are Hadoop ecosystem, Hadoop core components itself, which covers distributed file system as well as MapReduce framework. Second one is Metastore, which stores the metadata, and third one is the bunch of jar files. And then on top, there are different types of clients which can run Hive queries. We have seen Hive command line interface by running Hive command and getting into the command line interface. For now, that is more than enough. Hive is a web interface, so you will understand the command line interface and Hive interface more in detail by the end of this course, which is more than enough to kickstart as a ETL developer or ETL architect to build Hadoop, to build enterprise data warehouse using Hadoop ecosystem. Okay, that is about Hive architecture, and we have seen Hive Metastore. It is nothing but a database which will actually store the metadata. We have seen Hive configuration to get the details of our database, which is nothing but a hivesite.xml under /etc/hive/conf, And then if you want to override certain parameters while running the Hive, there are multiple ways to do that. One is at runtime by using the set operator, and the other one is by using .hiveRC for all the sessions that is initiated by that particular OS user. Okay, I will demonstrate that quickly. So what I'm trying to say is, when you do Hive, when you launch Hive, so like any other software, Hive also runs using bunch of parameters, and if you want to list all the parameters, you can run set command, and it will actually list all the parameters. You need to be familiar with a bunch of these parameters, and these can be from Hadoop itself, like HDFS and MapReduce, and some are Hive inbuilt, and some are system related. So there are a bunch of them, and I will show you a couple of things. This is one of the important things which you typically try to override at runtime. And by default, number of reducers by Hive queries will be determined when you actually run the query. If you want to override, you can use the set command. So first, let us see how you can actually view the value. Don't worry much about this parameter at this time. You will understand more about it later. At this time I am primarily focusing on the set command. So you can use set command and see the value of a particular parameter. It is -1. If you want to change it to, let's say, 2, you can do like this. So if you do not have equal to and value, then it will just display. If you have equal to and if you are customizing the value, it will actually set the value. Now if you run again the previous command, which is just set without equal, then it will show you the current value. So in some cases we might want to modify the parameters for all the sessions initiated uh, by a particular user, in this case Cloudera. Okay, so first let me show you the username which I am using. I am using Cloudera, and the directory I am in home directory of Cloudera. So if you want to customize for all the sessions that is launched as Cloudera, what you have to do is you have to go to the home directory like this, and then you have to do vi.hiveRC, and then you can say set paste equal to 2. Okay, for now let me gzip, let me rm dot hiveRC. Okay, now again let me show you Hive. It is -1. Okay, because we set it and we exit it, and if you launch it again, it will use the default values. Now get out of it. Now use the .hiveRC file, and you can paste, and you can set it to 2, and now you can launch Hive. Okay, now if you run the set command, it is 2. So all the sessions now you launch using Cloudera as user, MapReduce.job.reducers will be 2, unless you override at runtime. If you want, you can again override it here. End of 2, let's say 5, and now it will be 5. So that is all about .hiveRC and set thing. These commands will be handy at runtime to tune the performance of the Hive queries. Okay, and then few important commands. Hive can be launched using 3 ways. We have already seen Hive command. Now we will see Hive -e. So when you run Hive, it actually launches the Hive command prompt. Sometimes you just want to run a Hive query and come out of it. Instead of launching the Hive command prompt, you just want to run a query and come out of it like this. And then you can use -e, and you can do select count of 1 from cards dot deck of cards and hit enter. What it will do is it will launch the Hive, it will execute the query, and it will come out of it. So if you want to integrate the Hive commands with a shell script, then you can actually use Hive -e and put it in a script. So that is the purpose of Hive -e. And Hive -f, if you have bunch of Hive commands, and if you want to run it in a series, then you can use Hive -f command. It can only have Hive queries, it cannot have anything else. So there are 3 ways. One is Hive to launch the command line, Hive -e to run its individual Hive command. Hive -e is to run a series of Hive commands and come back out of the Hive instead of launching the Hive command line interface. And then when you run the queries, as any other software product, Hive also logs a lot of information, and the location is /tmp. So let me go back to here. See here, it ran the query and it came out of it. And now the control is again at the controller bash instead of Hive command prompt. Okay. Now if you go to /tmp, there will be a directory with the name of the OS user which you are running the Hive queries. So in this case, we are running Hive queries using Cloudera. So there will be a directory with Cloudera name, and you can do lsltr, and you will see hive.log file. So this is what it will actually all the logs will be logged to. So you can actually see details about all the queries which we have ran so far. It uses log4j.properties behind the scenes. So you can actually go back to cd etc hive conf lsltr. You can use hive log4j.properties to override the size of the hive log file and all those things. Let me show you. So here you need to understand these parameters, and they're pretty much self-explanatory. You should be able to understand. You have to use the reference. You have to use the Hive user guide for reference, and you will be able to play with it. Okay. So that is about Hive architecture. And if you want to override the log directory, log file at runtime, you can use these parameters. You can set these parameters to custom paths instead of /tmp/user to different location, so that each query logs into a different file. If you want to keep track of each of the query, and if you want to send alert to the support teams, then you might have to customize these locations. And now data definition language. Wait, one thing. Yeah. So that's it. I think this video is already beyond 20 minutes. So I'm stopping at this place. So we have covered Hive architecture in detail. As part of the next video, we will be talking about the data definition language of Hive. Okay. I hope you enjoy the video so far. See you in the next video. Thank you. Bye.